Hello everyone, we are going to talk about the unit circle, very famous unit circle. So we're going to learn how to develop it first so that we understand better how it works, and so we'll memorize it better, because this is one circle that you're going to have to memorize. So on the blank on the inside of the circle, we're going to start by writing the degree measures of the angle. And notice how I say here that theta is going to go from 0 to 360, not including 0. If you put a theta of 0, you wouldn't really have an angle, right? So I just specified here theta is going to be greater than 0 and less than or equal to 360, which means here technically this line should be below, because if I go all the way, if I'm starting on my standard position, so positive right axis, that would be 0, right? There is no angle there. And then I'm going to start opening my angle, and I'm going to go full revolution until I come back here, and so that first one here will be 360 degrees. Now if that makes you uncomfortable and you like to say, well, when I started 0, go ahead and do that there. So 0, and then you do your revolution, then it will be 360 degrees. Okay, so if I start here at 0, and I'm going to see how I have those little notches here on the circle. So if I go from here to here, if I will draw this angle right there, what will that angle be, right? That's what we want to know. So what will that angle be? We're going to go in 30 degrees here, so that's going to be 30. I'm going to erase that. So this here will be 30 degrees. Then if I go from here to there, that will be now a 45 degrees. See how it really cuts my quarter of the circle there nicely in half. So that will be my 45 degree right there. And then the distance from here to here, this is really just going to be 60 degrees. What I'm trying to say is that this is 30 degrees. And then we add another 30 degrees, will take us up here. And then we're adding another 30 degrees to that, it will take us up here. So if I add 30 degrees to 60, that will be a 90 degrees. Don't forget to write your degree symbol, right? Those are degree angles. Then I'm going to keep going, add 30 degrees to 90, so that will be 120 degrees. I'm going to skip this one for now, so I'm going to add another 30 degrees, which take me here, and that's 150 degrees. And then add another 30, that will be 180 degrees. And another 30 will be 210 degrees and 240 degrees. And from here to here, another 30 will be 270 degrees. And then that will be 300. Skip this one, go to the next 30, that will be 330 degrees, and if you add another 30, you will be at your 360, right? Oh, you didn't see what I was doing, did you? Sorry, I apologize. So I just kept adding 30 degrees, but I wanted you to notice that I did those angles, right? This one, this one, this one, this one. Yes, this one, 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 and this one. Those are all your 30 jumps, right? Now we're going to do 45 jumps. So this time, this is still going to be starting here, right? So that could be either blue or orange, really. And now I'm going to jump here, 45 degrees. And then I'm going to jump another 45 degrees, which is going to take me here, right? 2 times 45 would indeed be 90. Then another 45 will take me here, and then there, there, and I'm back there. Okay? So when I do those now, so that will be 45, plus 45 is 90, plus another 45, that will be 135 degrees, right? And then another 45 will be 180. And then another 45 will be 225 degrees. plus 45 will be 270, and then plus 45 will be 315 degrees. So now we just completed the most common degrees on the unit circle. By the way, what's a unit circle? It is a circle with a radius of 1 unit, right? Whatever that unit is, it's a 1 unit circle. Alright, so we are noticing that every angle is going to be a multiple of either 45 degree or 30 degree, right? So we're going to convert those into radians now. So what is 45 degrees in radians? So remember, to get from degrees to radians, we need the degree symbol at the bottom. So I need my 180 here. And then what's 180 degree in radian? That will be pi. And now I'm simplifying. So the degrees will cancel. I have 45 over 180, and that will be 1 over 4. So that will give me a pi over 4. So my 45 degree here is going to be pi over 4. And then I'm going to take the 30 degrees and I'm going to do the same gymnastics. So 30 degrees times, you want to cancel the degrees, so we need 180 at the bottom. And on the top, that will be pi. The degrees will cancel. 30 over 180, that will be 1 over 6. And so that will be pi over 6. And so that will be my 30 degrees there, pi over 6. And now we are just going to use that fact. Just like earlier, we added 30 degrees everywhere to jump from the blue notches, right? We're going to add pi over 6 every time, or multiply if we want to do a repeated addition, right? So that we can get all the blue notches. We're going to go by 30 degrees here, so by pi over 6 degrees. So this is pi over 6. Therefore, this one will be twice that, right? If that's 30, this is 2 times 30. Would you agree? So here I need to find what 2 times pi over 6 will be. Well, the 2 and the 6 will simplify, right? And that will be pi over 3. Then go to the next blue notch. So we now have 3 times pi over 6, right? We have it 1 time, 2 times, 3 times. So this is 3 times pi over 6, and that will simplify to pi over 2. And that makes sense, right? Because we already know that the pi is here. And so if from here to here, that's pi, halfway through should be half of pi, right? Pi over 2. And now I'm going to the next notch. So remember, we had 1 pi over 6, 2 pi over 6, 3 pi over 6. Now we're going 4 pi over 6, right? So this blue notch here is going to be at an angle of 4 times pi over 6. So what does that simplify to? 2 pi over 3, right? And then if that's 4 pi over 6, the next blue notch will be 5 times pi over 6. And when you cancel or simplify that, it doesn't simplify, does it? So that's actually your angle, 5 pi over 6. Then 6 pi over 6. 6 pi over 6 is just going to be equal to pi, but you know that already, right? And we're going to keep jumping to a next blue notch. So if this was 6 pi over 6, this one is going to be 7 pi over 6, which doesn't simplify, so that's your theta here. Then we're at 8 pi over 6, and that simplifies, divide by 2 everywhere, right? So that will be 4 pi over 3. And I'm going to keep going, so that was 8 pi over 6, so that's now 9 pi over 6. And that simplifies to 3 pi over 2, right? And if that's 9 pi over 6, this blue notch will be 10 pi over 6. Which you divide by 2, so that will be 5 pi over 3. And this one will be 11 pi over 6. And so that stays, right? That doesn't simplify. And this one will be 12 pi over 6, which simplifies to 2 pi. And again, if you wanted to mark the beginning of that angle, you could also say 0 or 2 pi here. That's not a division, right? That's an OR. Alright, so we just filled in our circle with all the radian measure for the multiples of the 30-degree angles, right? So now we're going to do the same, but for the multiple of the 45-degree angle. So this one is 1 pi over 4. So that's 2 pi over 4. But 2 pi over 4 simplifies to pi over 2, which we already had, right? So 1, 2, this one will be 3 pi over 4. Well, look at that. That doesn't simplify, so we're going to leave it as 3 pi over 4. 4 pi over 4 goes to your pi. 5 pi over 4. You can see that doesn't simplify, right? So that goes there. 6 pi over 4 is the same thing as that, so that's 3 pi over 2. Ooh, I keep forgetting that you don't see it up there. You will be in the room, you will tell me, huh? And then if this is 6 pi over 4, this one will be 7 pi over 4. And you can see that that doesn't simplify, so that's your theta there. And then this one would also be 8 pi over 4, which simplifies to your 2 pi. And so now we have the full circle filled in with all our radian degrees, right? So that's what we wanted to do here. Now we're going to keep going. So we are going to practice putting all of those radian degrees now, but we're going to write them on the inside of the circle this time, because on the outside we're going to do something else in just a minute, right? So let's see if we can practice that. So let's see, can I pause this video and restart it? I'm not sure. I don't think I can. This program will not let me pause. It freezes, but the time keeps going. Okay, so we're just going to fill it in quickly. So this one in radians, right? So that's going to be your 0 if that makes you more comfortable, but that will be 2 pi, right? When you come back a full revolution. This one we said was pi over 6, pi over 4, pi over 3, pi over 2, oops, my over. Then that would be, see if you have 1, 2, 3, 4 pi over 3, right? Simplifies to, what did I just say? 1, 2, 3, 4 pi over 6, sorry, multiplies to 2 pi over 3. And then this one will be 1 pi over 4, 2 pi over 4, 3 pi over 4. This one is going to be your 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 we know is just pi. Then this one is 7 pi over 6. This one is 8 pi over 6, which should just simplify to 4 pi over 3. Then we have 9 pi over 6, which simplifies to 3 pi over 2. 10 pi over 6, which simplifies to 5 pi over 3. 11 pi over 6 does not simplify, and your 12 pi over 6 is back to 2 pi. And now I skipped some pi over 4, right? So 45-degree angle. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. And we have them all. Alright, so we have all our radians. So now let's see what we're going to do. So we're going to switch down here for a little bit. And we're going to kind of relate the right triangle trigonometry with the circular trigonometry, right? We're going to kind of relate them. So when we did the right triangle trigonometry, remember, and if you're not sure, just go back to your notes, right? Remember I told you that even though normally we say the short legs are 1 and 1 for a 45-degree angle, I said when we deal with the unit circle, we like that to be our radius. So what I'm going to show you here is I want this triangle to be drawn inside my circle here. So here is my right angle, and therefore this angle here is going to be 45 degrees, right? And this one, of course, is also 45 degrees. So what I want, because it's more on my unit circle, see, I put the equation there of the unit circle, x squared plus y squared equals 1 squared, the radius, right? And so if this is 1 here, and I want that to be inside my unit circle, then my hypotenuse here has to be 1, right? That's what I want. And if my hypotenuse is 1, remember I told you that those two are going to then become square root of 2 over 2 and square root of 2 over 2. So that's what those two are going to be. But since I'm putting this triangle inside my unit circle with a radius of 1, that point is now on my unit circle, right? So it's an ordered pair on the unit circle. So what are those x and y values? Well, let's think about it. When we did the right triangle trigonometry, we said the sine of 45 degree, sine of 45 is opposite over hypotenuse. Hypotenuse being a 1, nicely, that would just be the opposite, right? And so what is the 45 degree here? The opposite would be this side, wouldn't it? And so look, would that not just give me the y value of that point, right? How high that point is? So that sine is just going to be square root of 2 over 2, which is my y value. So my y will be square root of 2 over 2. And then let's switch to another color. Let's go the cosine of 45 degree. So the cosine is adjacent over hypotenuse for the right triangle. So if I go in my triangle here, my adjacent is this one over my hypotenuse of 1. But will that not just be the x value of that point? And the adjacent, the adjacent here is square root of 2 over 2 over my 1, right? So the x value is also a square root of 2 over 2. So go back up here now. So imagine, and I'm going to do that in pencil because I don't want to mess it up completely, but just imagine that I'm drawing my angle here, my on position, standard position, 45 degrees. Now I can drop a perpendicular line from that point where my angle goes through, my terminal side goes through, right? I can drop a perpendicular line to the x-axis, and all I did was put my triangle inside my unit circle, so my hypotenuse is 1, and that ordered pair right here is going to have a y of the opposite over the hypotenuse. So that would be opposite of my 45, 45, 90. The leg here is square root of 2 over 2 over the over 1, which is just itself, right? And then the cosine, which is going to be the adjacent, that will give me the x value, and so that would also be square root of 2 over 2. So that's how we relate right triangle trigonometry to circular trigonometry, right? We just put that triangle inside our unit circle, and then we just play with that. So if I know that's true, that's also telling me a little bit more information. It also tells me that the sine is the y value, and it tells me that the x is the cosine is my x value, right? Because the cosine will be the adjacent to the angle. All right, so we're going to keep practicing on those. So if I take that triangle now, and I'm just taking it to this quadrant instead, and I'm going to drop it, my 45 reference angle, that's now my reference angle in my reference triangle, right? Because technically this angle right there would be 3 pi over 4, which is the same thing as 135 degrees, right? Technically, that's what that would be. But now I'm inside my reference triangle here, and my reference angle is 45, just like it was here. Therefore, those ordered pair here are going to be the same as those, with just one slight little difference. Remember I said your sines are going to be your y values. Well, my y values are positive in quadrant 2, no problem. But the cosine are my x values, and what are your x values in quadrant 2? Those x's are all negative, so I need a negative here. So they're the same, except I need a negative. And because now we know that, I don't need to draw the other triangles for you, do I? You could just put another triangle down here, drop it to the x-axis, you'll have your reference triangle, and then you will know that those ordered pairs are going to be same. But which one of those is going to be negative in quadrant 4? The x or the y? The x's are all positive here, right? So the y will be negative. So this one. And then do your reference triangle here, and you know that those ordered pairs, this point here is going to have ordered pair square root of 2 over 2 and square root of 2 over 2, except the x here has to be negative and the y has to be negative, right? Alright, so we did the 45, so I'm going to erase what I had here. There we go. And now we're going to do the 30, 60. So I'm going to draw my little reference. So here is my angle. And that angle right there will be 30 degrees or pi over 6, right? We're really talking radians here, so it's really pi over 6, but it's the same thing. And so my reference triangle will just drop to the x-axis with the right angle. So I know that will be 60, but I don't care, right? I want this angle right there. That's my reference angle, the one that lies on the origin, right? We talked about that last time. Okay, so if I'm down here now, I need something about the triangle 30, 60, 90. So let's go back here and let's say, okay, what do we know? If this is a 30, then that's a 60, right? And 90. And so if we recall the short leg, remember we can't just go by the looks, right, in geometry. The short leg is across the smallest angle, so the short leg will be here. I want my hypotenuse to be 1. Normally it will be 2, so because I'm dividing that by 2, I'm going to have a short leg of 1/2 instead of 1. Remember we did that last time. Again, if you don't remember, just flip a few pages back in your notes and check that out, right? And then we said that this leg, which really will be across from the 60-degree angle, so it's the longest leg here, that will be square root of 3 over 2. Now if I take that triangle and I'm putting it in my unit circle, this angle right there will be my 30 degree or pi over 6, right? That's my right angle. And I'm looking for this point here. I want to know what is that ordered pair right here. So if this is a 30-degree angle here, then the sine of a 30 degree or pi over 6. So the sine of 30 will be opposite over hypotenuse, which is always 1, so it's just going to be 1/2. And remember, sine, so if that's my 30, the sine will be opposite, so that is my y value, and so my y will be 1/2 here. And then we want to know what is the cosine of 30 or pi over 6. And so the cosine of 30 is the adjacent, right, over the hypotenuse, so square root of 3 over 2. So this here, this leg, is going to be your square root of 3 over 2, so that's your x value. So that's your x value. This one is your y value for each point. And so now we're going to fill those up here, right? So if I'm on my triangle now, I know that this point right there is going to have ordered pair. We just said square root of 3 over 2 and 1/2. Okay? Now we're going to skip the one that goes to 60 degrees, we're just going to do the 30 reference triangle I'm talking now, right? So in quadrant 2, the 30 reference triangle will be right there, right? That will be your 30 reference triangle with a 30 degree angle right there, or pi over 6. So I'm jumping to this one. I need you to pay attention to the symmetry. You see how my x and y axis here, this point is exactly across from that one. So the ordered pairs are going to be the same, aren't they? So that's just going to be square root of 3 over 2, 1/2, except the x value in quadrant 2 are negative. So I need a negative there. The y is a positive, so no problem. Okay? Now, from here to that other pi over 6 angle here, that will give me another reference angle of 30 degrees right there, right? The triangle will then be drawn up here in quadrant 3. So this angle is the mirror image of this one, right? So their ordered pairs are going to be the same, with one slight little difference. The x's and the y's are negative in quadrant 3. And now we can either mirror that point with this one, or we can mirror it with this one. It doesn't really matter, right? Because this will be my next here reference triangle of 30 degrees there, or pi over 6. So those 2 points are going to be mirror of each other. So I'm going to have a square root of 3 over 2 and a 1/2. But my y values are negative here. So there we go. Alright, so now we're going to have to go to the 60 degree triangle. So let me erase this reference triangle. And let's do the 60 degree. So here will be your terminal side, right, for 60 degrees, or that will be the same as pi over 3, right? And you're dropping a perpendicular to the x-axis for that reference triangle, and here is your reference triangle, right? So it's nothing more than this triangle, but instead of having the 30 degree angle now on the origin, we're going to have the 60 degree angle on the origin. So just see it up here, right? So if the 60 degree angle is on the origin, then we're going to have sine of 60 degrees So if this lies here on the origin, sine of 60 will be opposite over hypotenuse. So that will be now square root of 3 over 2, and that's my y value. And the cosine of 60 degrees, the cosine of 60 will be adjacent over hypotenuse, so that's 1/2 over 1, which is just 1/2, and that's your x value. So we're going to go back up here, and we're going to fill in what we just find out. So we said the x value here is just going to be 1/2, and the y value is square root of 3 over 2. They're both positive because we're in quadrant 1. So now we're going to imagine that we're drawing the reference angle here, which would now go back down here, right? So that will be this one, just like the mirror image across this way. So this point is going to be the mirror of this one. So that point is going to be 1/2 and square root of 3 over 2, but the x's are going to be negative. Mirror image down there, right? You see the symmetry. So those 2 points are going to have the same ordered pair, or almost. We have a 1/2 and a square root of 3 over 2, and both x and y are negative. And now we're going to finish this one. So it's the mirror of my one up here, right? So it's going to be the same ordered pair, almost. But the y's are going to be negative, right? All right, we're almost done. We just have to finish the points on the x-axis, on the y-axis, right? But those are just ordered pair on the axis, right? So what is that point? If my radius is 1, then that point will be 1, 0, wouldn't it? And if the radius is 1, then this point will just be 0, 1. this point right there will be negative 1, 0. And finally, the one down here will be 0, negative 1. And there you have your unit circle. Now we're having only the radians drawn on this one. And I will suggest that you fill in your degrees in there. And I'm going to show you my unit circle that I use. And I'm going to put a link of this blank one for you because they're online, they're free, and you can use them and practice to know them by heart. So see how I have all my degrees in one color, all my radians in another color, and then all my ordered pairs. But I use different colors for my sine and cosine, right? For the x's and the y's. All right, so unit circle, here we go. Now we're going to use it. The value we said of r, the value of r is 1, right? Because my radius is 1 everywhere on that circle. And so for each point xy on the unit circle, right, for any point you pick on this circumference of the circle, the sine would also always be y. Well, the sine is always opposite of hypotenuse, so the sine would always be the y value over 1. So the sine of theta, remember you always need to put an angle inside the trig function. You cannot just write sine and leave it blank, right? It's just like you would never write the square root and leave it empty and not put anything in it, right? Same thing with the trig functions. You need to have an angle in it. So the sine of theta is always going to be equal to my y value inside the unit circle, right? Because it's opposite of hypotenuse, which is always 1. So the cosine of theta is always going to be equal to adjacent, which is my x value, over 1. So that's just x. And then the tangent, well, tangent is technically going to be opposite over adjacent, which is going to be sine over cosine, which is going to be y over x. And now you do remember your reciprocal functions, right? And we're going to look at those in a minute, and we're going to see how those, you just take that and you do the reciprocal. So therefore, any coordinate, any point on the circumference of the unit circle is just going to be, we can rewrite it as just saying xy. We can say it's just going to be the cosine theta and the sine theta for the y. That's how we can look at every single point. That's your cosine, that's your y. So if I give you a point and I say, can you give me the cosine? Sure, it's the x value. All right, so we're going to relate still the right triangle definition with the circular angle of the unit circle definition, right? So sine of theta, we said in the triangular trigonometry that would be opposite, and I'm going to make that short, right? So it doesn't take too much time on the video, over hypotenuse. So if this is true, opposite over hypotenuse, what did we say that was going to be for the unit circle? It's just your y value. Now I want to put a little note here. And I'm going to say if r is not 1, meaning if you would not be in the unit circle, then what would the sign be if it's not in the unit circle? It will just be then sine of theta will just be equal to y divided by r, whatever r would be, right? Because that's your hypotenuse. But we're working in the unit circle here, so it's y over 1, which is just y. The cosine in the triangle used to be adjacent over hypotenuse, right? So this would just be the adjacent side of my angle. I need to put my angle theta would always be there, right? That would be my x value. And again, if you would not be, if r is not equal to 1, then your cosine theta would be equal to x over r, whatever r is, right? Your tangent in the triangle used to be opposite over adjacent, which for us means y over x. And that will be the same no matter what the radius is. Because if you have a y over 1, a y over r divided by an x over r, those r would cancel and it would end up being y over x anyway, right? So here it doesn't matter. Now we're going to go to the cosecant. So remember, the cosecant is the reciprocal of the sine, right? We can only have one co in the function and its own reciprocal. So it's this fraction or ratio, the reciprocal of it, right? So therefore, the cosecant in the unit circle would just be 1 over y. The secant is the reciprocal of the cosine, so that's hypotenuse over adjacent, and so that would be 1 over x. The cotangent is the reciprocal of tangent, so that used to be adjacent over opposite, which for us here is going to become x over y. So that's what we want to think about. Now for the signs, and we already touched on that when we filled in our ordered pairs on the unit circle, right? Quadrant 1 is going to have all the points, all the x's are going to be positive and all the y's positive, right? So if everything is positive, all of those functions are going to end up being positive. So in quadrant 1, which one are positive? All 6 trig functions, all of them. And I'm not going to write them all, we're going to say all of them. In quadrant 2, when you look at an ordered pair, you're going to have a negative x but a positive y, right? Well, if your x is your cosine, then this one will be negative. The sine is your y, will be positive. So the reciprocal will have the same signs also, right? But remember, your tangent is going to be your sine over cosine or your y over x. So if you have a positive over a negative, the tangent and cotangent here will be negative also. In quadrant 3, all your ordered pair will be negative, negative, right? All x is negative, all y negative. So here we're going to have the sine and its reciprocal negative, the cosine and its reciprocal negative, and tangent being sine over cosine, negative over negative becomes positive. And I didn't finish writing here. So in quadrant 3, the ones that are positive will be your tangent theta and its reciprocal, right? And in quadrant 2, we said the ones that are positive will be your sine theta and its reciprocal, which is the cosecant theta. In quadrant 4, your ordered pairs will be positive for the x's, negative for the y's, right? So since my y is sine, that will be negative. Cosine is your x, that will be positive. Tangent is y over x, so that will be negative. So the positive in quadrant 4 will be your cosine theta and its reciprocal, the secant theta. So that's for the signs. And I know this is getting long, but this is going to be very critical. So I'm going to stop this video and then we're going to use the unit circle and do a little bit of math with it in the next little section. So I'll talk to you in just a few minutes.